Hi, this is Chris Kiefer, and welcome to the Power of ERDC podcast. Today, we're exploring a pair of unsung teams whose efforts magnify ERDC's research capabilities. That includes 3 fabrication shops where master craftsmen, welders, machinists, and model makers turn researcher concepts into a tangible reality. Joining us to discuss these shops is Zach Smith, Program Manager of ERDC's R&D Fabrication Group. Zach, it's good to have you today.
Thanks for having me.
Yeah, absolutely. And meanwhile, ERDC's Directorate of Public Works, or DPW, is responsible for maintaining the organization's facilities and infrastructure, including the massive demands for power and water to accommodate large-scale research projects. Joining us to talk about the Directorate is DPW Chief Jonathan Howell. Jonathan, thanks for joining us.
Great to be here, Chris. Thanks for having me.
Yeah, so I guess I want to really kind of start for both of you kind of at a high level explaining for general audience kind of what you do and how it supports ERDC. And so, Zach, I want to start with you. Can you kind of talk about the high level overview of ERDC's R&D shops, what they are and the kind of work they do?
Yeah, so we consist of a welding shop, model shop, and machine shop. Our support is more or less geared toward a warfighter, the civil work side of USACE, and so that they're able to complete their mission. And each shop, I think we're roughly around 27. Well, as a whole, we're around 27 people. We have welding capabilities, we have the model shop, the machine shop, all your CNC features. Each shop has a CNC feature, and that's probably about it.
Yeah, and we'll drill in a little bit more kind of as we go. But I mean, to kind of simplify, I mean, a lot of what's master craftsmen, you said 27 people, variety of skill sets, but a lot of what you guys are doing are building various things that researchers use, whether that is for physical models, for, we do a lot of hydraulics research and flumes and whatnot. I know you do stuff for like explosive research that we do and so forth. And you guys are supporting them by building stuff that enables their research.
Anything, it's going to be prototype or scale type modeling that we support. We build a lot of things.
Yeah.
And things come in on napkins, things come in on prints, things come in just off the street. Hey, can you build this? And then we're able to accomplish those tasks.
Yeah. So. Yeah. And I want to pull on that thread a little more in a second, but Jonathan, tell us kind of similarly, again, for someone who's not familiar, DPW, what it is and kind of its mission and the kind of role it has to support ERDC.
Well, Chris, just like you said, it's the top level is infrastructure and utilities. So roads, water lines, sewer lines, gas lines, electrical transmission. We are the group that maintains the facilities so that the research can be performed. In some cases, support the R&D shops with R&D capabilities within those facilities where the trades are appropriate. So we have electricians, we have plumbers who support the welders in some cases with pipe fitting and bringing the water to a research model or the electricity to a system for that research to be performed.
Sure. So in both, I mean, it's kind of a supporting, enabling the research to happen. I mean, couldn't happen without a lot of the stuff that you all are providing. Talking, Zach, first, kind of again, drilling in more in the kinds of work you all do, maybe kind of even walking through the various shops. So start with the model shop. And I know we mentioned hydraulic models and building the physical models to go in that. You kind of give some examples of some of the stuff you do and processes.
So we're starting a new system now called WellMos, and it's eliminated a lot of the concrete bathymetry. The model shop, primary user of this patent, I should say.
Mm-hmm.
So it comes in as a STL line file, and from that point, the guys will take that line file and start cutting the foam, and then from there, then it'll go to bathymetry, a drawing, an STL, and then they'll cut that bathymetry, and then from there, it's coded, taken to the project, and then installed, and then from there, we rely on Jonathan for water and electricity.
Sure.
So, and they also, there's a lot of acrylic work done in there. We currently have section models that we're working on that include Keystone Dam. We have Ensworth empty and filling station that we're working on as well. So, I mean, that's primarily, CHL is primarily the feed for the model shop.
Yeah.
And then GSL, more or less, machine and welding. Machine shop, I mean, they can build anything.
Yeah.
Anything with any kind of alloy, I mean, they're your guys. And then my welding shop, same thing. They're geared more towards survivability, IEEB and such, and they do a lot of structures. They get blown up. So
Yeah. So on that, I mean, as you said, GSL does a lot of work on explosive effects and whatnot, and so that's a lot of what you all are supporting as well. Structures for those different experiments in various components, and like you said, anything. I think I know we've talked on the podcast and various things with submat, and I know when I was over there, you gave me a tour the other day. I mean, I think they're working on maybe anchors for the system. I mean, there's like all kind of various things that you could, people can't even think of.
Working on some stuff with the air right now.
Yeah, sure.
Some anchoring, mat anchoring, so.
So I say that to say it's a variety of things. The researchers need that people on the outside might not even think about. Do this experiment. I need X, and you mentioned they'll come to you. I mean, talk maybe a little bit about what that process is like, and maybe using a model at CHL might be a good way to explain it. A researcher at CHL is going to do an experiment. There's a new lock and dam. They want to do it in the physical model, see how X change is going to look, and so they're going to put it in the flume. So they need to build that dam, model that dam. They'll come to you. Maybe they'll have a sketch on a piece of paper.
Comes in.
How does that go?
It comes in as a sketch.
Yeah.
90% of the time, it comes in as a sketch, and then from there, they'll want a rough estimate, and we'll build a rough estimate, which is usually a little beefed up. But from that point on, they'll get us a better drawing, and then from there, we get it pulled up on the CAD and start tearing the actual model apart, looking at what it's going to take to build it, and what materials it will take to use, and then from there, it's more or less it's fabricating and assembling everything. So once we get through that part, then the installation begins. So, and then we get to see the end product of what happens. A lot of stuff we do is for lock and dam traffic and erosion.
Yeah.
So on the model shop side of things.
Yeah, sure. You mentioned WellMos, which I think is kind of a really important thing, and it's probably a good time to kind of talk about it in the discussion. These models, again, to explain for people who aren't familiar, we've got flumes, and in the flumes, we might try to mimic a certain waterway. That's where you've got to do the bathymetry and so forth. So the water flows here, similar to it would in the Ohio River at such and such a dam. Used to all be done with these giant concrete blocks.
They did. 2017, I think, was our last one.
Yeah.
And
tremendous amount of time.
That crew, the construction crew that we had, they had all retired or moved to different labs.
That's such a fine skill to be able to do that.
It is. So we had to come up with an alternate. And I can't say it was just Jeremy Sharp and Duncan Bryant and I. It took a whole team of individuals to come up with this idea.
Yeah.
So, and
So tell us about how you do it now.
so the Wellmost now, it's just a block of foam that comes in, and it's machined, and then the guys will coat it, and then it goes out into the model, and then each block, and these models may be 3,000 to 7,000 square feet.
Mm-hmm.
So it's a lot of foam, and
Each block is how big? How many blocks?
4 by 8.
So yeah,
So they're
hundreds.
very large blocks. Yes. And they'll differ in size. They go from 3 inches all the way up to 24 inches of thickness.
Sure.
So,
And they'll all be shaved, cut, matched.
everything will have bathymetry, and they'll have a bathymetry.
Yeah.
So
that way they'll perform similar to
what's in the real world, for what data has been collected to more or less bring that bathymetry to life.
Sure.
So,
kind of moving back to DPW, and again, to kind of explain, more than just, managing infrastructure and facilities and so forth. How is that a unique job at an R&D organization? I'd imagine, again, we talked at the beginning, the power and the water demands at the very least, I'm sure, are unique than managing infrastructure, just anywhere.
So, of course, we've got the regular upkeep, as you say, their office buildings or their research facilities and their offices there are restrooms there. But as the research is performed, there are structures inside that are physical, and where the bathymetry models are placed, we helped to construct those in many cases, to get the concrete poured, to set the plans, specs, and drawings through a construction division to have that built up. And then it has to be maintained. So, of course, there's the regular work that you would think of a plumber or an electrician performing, but then there's the dynamic, the day-to-day changes that come along with where a particular sensor may go, making sure that the demands of a circuit panel are not exceeded, so that the research can continue uninterrupted.
Sure. And then in addition to that, we've also got computing power, high performance computing. They use a little bit of electricity too. I imagine.
Yeah, so it's a quite hungry for electricity, and so we have our own substation here at ERDC. Not a lot of people know that, perhaps, with 2 big 1 megawatt transformers that carry all of the load. So independent from the electric company that provides power to ERDC, we maintain the transformers, the transmission lines, and all of the capabilities that supply power primarily to the ITL's high performance computing center. And then it also has to be cooled. So the evaporative cooling that goes into making sure that it doesn't get overheated across the station.
So I'm sure just that in itself is a pretty demanding task.
It's not something that, a service interruption has a big consequence at this facility. So we do have 24-hour a day response expectations. When there have been service interruptions, the crews get out very quickly and make sure that the capabilities are restored immediately, or in as quick a turnaround time as possible. I'd like to think that recently we've seen improvements to the infrastructure so that the interruptions are fewer than the past and farther in separation than they had been as well.
Yeah, absolutely. And maybe kind of even along those lines, just talk about how do you anticipate the needs of the labs? I'm sure that they're all ever changing, and particularly with this pace of technology, ever growing and so forth. Kind of how do you anticipate? Can you maybe give an example of some, sometimes you've had to do that?
So the principal investigators are really good about talking to their technical directors in the labs about what they have coming in. And facility managers will coordinate with DPW in most cases, saying this work is coming. And so there have been instances where we've increased our water line main so we could increase the amount of water that is consumed by the lab, by the center, that is, at each individual lab. We get indicators of new equipment arriving or new capabilities that are being obtained. And in the design process, usually there is a component for the utility requirements. And so we stay engaged with that master planning to ensure that if we do have a shortfall, that we plan on how to bring those extra capabilities to bear so there isn't an interruption.
Sure. Construction, I guess, is another thing we haven't really gotten into, but particularly in terms of like specialized, talk about kind of what that looks like for you all, and even maybe examples of things you've had to put together, construct, whatnot, to support research.
So the traditional research, of course, goes through our construction districts, but we do have in-house capabilities. We have engineers, we have technicians, facility specialists, along with our tradesmen, our craftsmen who can support the construction activities. They have been involved in remodeling and renovations of spaces inside of the laboratories. I think a big one here recently, I think one of the facilities was just about completely renovated. So all the support space for the ongoing research was updated, basically brand new, rather than call it construction, but that's essentially what it was. Our tradesmen came in and erected walls and installed doors, and the engineers made sure that there was sufficient airflow for good working conditions during the research that was being performed. So a on-the-fly adjustment that didn't require a whole lot of contractual obligation and negotiation, that just made it happen, much in the way that Zach's crews are able to adjust for prototyping and supporting research when they find something and have to make a change.
Sure. For both of you, you talk about just how the work that you're doing in DPW, in the R&D shops, are enabling ERDC's world-class research capability. And again, these projects that we talk about all the time, how it kind of, what you're doing is allowing that to happen in a way people probably don't even realize.
Well, we're customer responsive, and we're here. So it's a built-in capability. It's a immediate access, and I know that
It's like a one-stop shop.
Well, there you go.
I sum it up that way.
We like to say yes to our customers.
Yeah, there's no.
Have a big demand, certainly, but we're here to support the researchers.
I think the thing you mentioned to me the other day is also no change orders. I mean, when they're coming to you with a project, and maybe this will apply, more in the shops, and they've got an idea for something and they've got to change it on the fly. It's a lot easier than were they having to contract with someone to do that.
They can just come down to the shop and say, hey, I'd like to make this adjustment to it, and that's it. It's not like having a contract where you got to turn in a change order and add money and such. It eliminates that issue.
Yeah.
So
you used a phrase when we were talking the other day about the impact of the R&D shops. Do you remember what it was?
I feel like the R&D shops is like a main vein to ERDC. I don't feel that that ERDC could run without how I say this, but
it supports so much.
What
we
support,
yeah.
We're the main vein. That's the way I see it.
Yeah, I like that. And DPW in a lot of ways too. I'm sure for most of y'all, it's just a lot of pride when you see some of the work that comes out of ERDC. And
it's that responsiveness, I think, that is the multiplier for the capabilities. Certainly on the facility management or the facility maintenance side of things, many of the capabilities do exist outside of the gate, but that vendor's capacity to respond is not as immediate, perhaps, as with our built-in capabilities. And the guys, the team does drop what they're doing and respond to the phone call pretty much on a daily basis.
Sure. Brother, tell me about your teams and experiences they bring, capabilities they bring, and so forth. I just go left to right. I'll start with you, Jonathan.
So a pretty mature team now. There are facility teams from the DPW in Hanover and Champaign and here in Vicksburg. There are about 50 personnel on the team now. They're wage grade craftsmen. There's technicians, facility specialists, and engineers who can produce plans, specs, and drawings for the operations. I think these are all professionals at the highest grade of capability that would be found out in the competitive marketplace, and we're always trying to find ways to expand their skill sets. So whether that's through online training or bringing sort of the innovative capabilities that are in the marketplace to our team, we're always looking to make sure we're satisfying what needs to be done for the researchers to keep the facilities operating at the best possible levels.
Yeah. I just touched on what Jonathan said. I mean, my group I think it consists of they're all master craftsmen. They all have a skill set. Actually, some of them have more than one. I mean, we've got guys that have 7 skill sets. It varies from plumbing, sheet metal mechanic to, welding, carpentry. It's all of them. And just having that capability alone is, makes the shops unique. And I work with a great group of guys that make that life down there very, very easy.
Sure. Work well together.
Yes. Everybody works well together. We're a big family. So
in terms of the capabilities too, talking about the equipment, and even kind of some of the upgrades y'all been able to do through the years, but all the various things that you have, and
so
what it allows you to do.
In the welding shop, they can do just about any kind of welding. We have a CNC plasma cutter, so those capabilities are available. We also have a new laser welder. Machine shop, just about any CNC Haas machine you can imagine we have. So we do have a new wire EDM machine coming in, and I think it's 7-axis. So that capability is going to be something unique to have, especially here on ERDC. And the model shop, we've got 2 5-axis routers. We have a 4-axis router. We have a 3-axis. We have 2 water jets. Table size, use it around 120 to 60 inches.
Sure.
By 60. So
3D printer too.
We do have a 3D printer.
Yeah.
It prints clear.
And
it's an SLA printer.
Sure.
So,
and you can use that for different parts at different times. I think even some of the models, you were showing me how you have some specialized things that you can just now.
A lot of things in the past, we'd have to build molds.
Sure.
And with the capability of having this 3D printer, we can load the file on there, and it produces an already working part. So it's done cut the labor well in half. So
yeah,
it'll do gates and such like that. But it's nice.
We talk again about enabling ERDC research and just the breadth of things that you all are able to support. Do you all have a good story of maybe a particularly challenging project or a researcher came again with an idea for something they needed built that you're like, I have no idea how we're going to do it, and you pulled it off? Or likewise for you, maybe some sort of band, whether it's construction, infrastructure, whatnot, that's going to be a doozy, and then we're able to get done.
There's not, and we've had this conversation, there's not one that really stands out to me other than I got to thinking this morning.
Yeah.
MVK contacted us.
That'd be the Vicksburg district.
Yes.
Like you say,
first part of December. And something happened on, I think it was the Ouachita River, and had a lock failure. So barge traffic was shut down. And they reached out to a vendor to see about getting the pin made. And the vendor told them it would be 12 weeks before they could get the part built.
Yeah.
Well, they contacted us and asked, hey, is there any possible way you could build this pin? And we said, yeah, not a problem. So they brought it over, and we built the pen in 12 hours, and it wasn't 12 weeks.
Yeah.
So barge traffic was shut down, and we got them out of the mine. So
Yeah. Do you have?
So I would like to think, creative problem solvers. So not necessarily even a facility related matter. So we have craftsmen who can build, like Zach's carpentry crew, shipping boxes. And in some cases, we're exporting the model or the capability for advertising with a prospective sponsor. And I recall a request had come in for a short notice, build a shipping box to transport a very large item. The transport was going to arrive the following week. And so it was basically all hands had to gather to get supplies, to fabricate the capability to safely, securely ship the item without it being mishandled as carefully as possible. And it was delivered as needed, unharmed.
Yeah, sure. It's talking about the pride in your jobs. I mean, when you just different stories. I mean, again, when that happens, when a research experiment goes off, maybe even get some news that you had a hand in doing. I know we talked the other day about even previously some of the projects that you were involved with when you were in the I'm blanking on what you told me the other day now. But just talk about some of the just kind of moments of pride when, again, maybe you've done something behind the scenes, but when it happens, knowing, hey, I had a role in that. I think it was out in Utah at the
Dugway Proving Ground.
Yeah.
When we were doing blast effects and atmospheric pressure tests, and that was pretty unique. We had built 9 sea huts, and they were doing several different charges to see how much atmospheric pressure was sucked out of the air, and then what we built. Some of those units withstood those blasts, which was pretty fascinating to me.
Yeah, sure.
So,
and maybe asking that question, I'm gonna let you kind of answer it in a different way. I mean, just kind of what brings you satisfaction in the job that you do?
I think the interaction with all the people, and the finished product that we build, is what stands out to me more than
knowing that we are part of getting that job done, that it does make a difference.
Sure. Awesome. Well, thanks. That's a question I have. Is there anything I didn't cover that you all kind of wanted to make sure we mentioned in terms of, again, DPW, the R&D shops?
Well, I'll just say that DPW can be contacted. There's a work order desk. There's a link on the SharePoint site. We take phone calls and walk-ins, and as mentioned, we like to say yes. We try to solve those problems when we're aware of them. We can't fix them when we don't know.
Sure.
If you don't know where the R&D shops is, I recommend you come down and visit us. It's easier to see what we do versus me telling you.
Yeah. Yeah, absolutely. Well, thanks again. Thanks both for taking the time and joining and talking about the work you do. And more importantly, thanks for the efforts that you do in all of your work and really enabling ERDC to do the things that it does. And again, I know it's a tireless job that doesn't always get a lot of attention, and I'm glad we're able to kind of maybe shine a light on here. But thanks for all you guys do, and thanks for being here today.
Appreciate it, Chris.
Yeah, absolutely. Well, that's all we have for today. Thank you for joining us. We remind you that you can go to poweroferdcpodcast.org for more resources about the podcast. We will, along with this episode, we'll have some kind of pictures or some pictures from the R&D shop and some of the work that they do, so you can kind of see it and understand it better. On the website, you can also find videos of past episodes, audio versions of past episodes, and follow ERDC on LinkedIn. That is also where you can see the live releases of all of these episodes. So thanks again, and we'll see you next time.